We're here now.
We can see most of it.
Resize.
Try again.
Resize Internet Explorer. Click on resize again.
Can someone still?
We come back.
Can't you just resize it?
Last time.
Can't you just resize the window instead of?
Because the end will never have anything anyway.
Excuse me?
But this will be the right.
Yeah, and you can't change resolution.
Sure, I'll
Press this button twice before adjusting the size.
Okay, anyway, while you're adjusting, I'll try to make myself.
Okay.
Some people might have realized I've been working quite hard on the wireless, so this piece hasn't been finished yet, I'm sorry, but you all have connectivity with. I'm talking about the technical parts of the technical practice analysis, and now this is doing more the legal things, so I'll try to avoid some of those questions. The picture that you see there is a picture of the switch of the Amsterdam Internet Exchange. We have a very strong suspicion that the digital tapping room is connected to the switch. I'll be honest, we thought it was port 17, but it's empty. Okay, what's been going on? You can?
Just resize the window then.
Thank you. Okay, the tapping documents have, there are two documents. Basically, there's one document called the func spec, functional specifications. And basically, it's a sort of bridge between lawyers and engineers. It sort of tells you what the government intends you to do and what kind of information you want to have. The second part is the actual technical specification, which is meant for the people building boxes. There might be issues. Is Elias van Dijnem in the room? Probably somewhere. This company is built one of the boxes. I haven't seen it yet. I look forward to seeing it at some point. Okay, these documents are written by various government organizations and ISP corporations. The status of these documents are to some people unclear. I think they're fairly clear. Okay, functional specifications. First, what needs to be tappable? What needs to be interceptable? I will use these terms intermittently. Tapping, lawful interception, target, suspect. It's confusing for me. It's the police likes to speak about interception, data, and target. They like to be militaristic, while I tend to do more the potential suspect thing. This is a different opinion. What needs to be interceptable? The activity of the suspect, which means everything is when he's logging in, where, what time, the location information, where is he, which pole, is he south of the Netherlands, is he Amsterdam, where is he calling from, what's the caller ID, what phone, house, wherever, GPS coordinates, is available, everything. And of course then the content of the communication. How does this need to be stored? Okay, first of all we need to transfer it according to another document specification, the the transport of intercepted IP traffic. We'll come to that in a little bit. Some of the goals of the interception are to send the data as soon as possible to the local agencies, minimize the people that are involved. In principle, only the security officers are supposed to know that there's stuff going on at the ISP. Apparently we have security officers here as well. I'm not sure if I'm one of them, but second, the information needs to be hidden. If there's stuff going on, of course, no one is allowed to know that the stuff is going on, especially not the suspect. The minimization of the people, we'll see that everything has been set up to optimize this perfectly. You can see that the ISP contact is ready to be phased out. No one at the ISP will soon know that they're being tapped, that their tap machine is running. Protect against tampering, they do this with some hashes and encryption, and the encryption also protects against eavesdropping. There are currently two types of tabs. One is the IP tab, which basically means everything the user does will be transferred to the tapping room. They can see everything that's IP. It's fairly standard. When the user becomes active, the machine starts tapping, data starts flowing. A mail tab is slightly different. It's a second type of tab that's defined because when an email is sent to the user and the user hasn't fetched it yet, the police would like to see it already, so that they might do something with the data and actually use it to find or monitor the suspect. In the future, there might be more types of tabs. They didn't specify anything except they gave an example of the ICQ tab, which is interesting in that the ICQ protocol is proprietary. So how are we supposed to tap this information if we're not supposed to know the protocol? And reverse engineering is being phased out in the free world. So okay, we'll get to the transport intercept IP traffic. Again, there's a copyright on both documents have a copyright on it, but they're freely distributable, except they're made hard to get by registering with telco organizations, which cost lots of money. But documents themselves state that they're public, as long as you don't edit them and send out weird information. They can be retrieved on various websites. Okay, the transport works in three handover interfaces. The first interface determines how things are set up. The tapping room and the ISP need to know that they're talking to each other, that they're talking to each other securely. Therefore, there are a bunch of certificates and encryption going on. There are two major ways to do the encryption. One is IPsec with Ike. No Twitter is Ike. You set up, the warrant comes in, it specifies a bunch of keys, and the connection is set up. I'll talk a little bit more about it later. Handover interface 2 is the meta user information. Again, when he logs on, what IP number does he get, when is he gone, when does he time out, when does he off or all the things that are normally creating syslog entries on an ISP server, those sort of events they want to know about. And then of course the interface 3, which has the actual data protection there. Okay, hand over interface 1. The problem here is, of course, that we need to have certificates in place. Now, how are we going to get them there? As far as I know, it's been brought up big. There's a CA called Digno Tower, Digno Tower, which has been suggested to handle all these warrants and API structures. I haven't checked them, I haven't seen it actually keys, but I wouldn't be surprised if the API isn't that public actually, and that only the parties involved would get keys beforehand. The warrant is written in XML, which should be a nice, clear language with no problems and very clear to read and understand what's going on. We'll see in a second that there's no real DPD to it, and we only have one example in the appendix, and there are various errors, at least in the example already, and a few omissions. Another controversial point is how do we identify who gets the tab? Sometimes it's very easy. You can say user with this phone number, user with this email address, the username, list of IP addresses and times so you can cross-reference. So usually you should be able to find the user, but the government sort of reserves the right to come up with other plans to tell you how to trace the user. Which, for instance, might be difficult if you start doing SSL and webmail versions and you don't log into it directly. And it becomes harder to trace. They keep opening options to have other means of identifying the user, which in a way is a good thing for us because they make the process less automatic. We have no clue, but we're going to get this in XML. It's going to be manual labor to figure it out anyway. The large variant is also set in the XML. I tried to have the XML example online, but I think that even though I put an XML tag protection around it, it's still interpreted by our browsers. So can anyone hear this? Is it better? Okay, I'm trying to speak a bit louder. Sorry. Now, the best thing I can probably do now is to get the PDF file because this browser can connect to it. So let's use the files. Oh, you see here that there are two versions. This 020 version doesn't exist officially. I haven't seen too many changes either. They were not very noticeable. Let me quickly switch to the XML example. Okay, we see the warrant number of delivery points. There can be multiple agencies who want this information, and especially if you think of the cybercrime treaty, you can imagine that multiple governments will want to receive this information. Since this standard is becoming a European standard, you can imagine that one suspect's data would be sent to a few countries. The IP number of the unit receiving the information is there, the certificate is there. The target key is a sort of unique identifier for the government so that they can keep track of who they're tapping. Like I said, there are a few errors here, and it's because I think the format is horrible for automation. Okay, the judge's name. Of course, warrants are always issued, at least in the Netherlands, are always issued by a judge. So you should sign it, and you should be able to verify the signature. I don't know. I haven't ever seen a certificate from a judge yet, so I don't know where they are. Also, the warrant time can be set in this specification, and I'm not sure if they actually. The specification doesn't enforce the time period. The legal time period is, I think, 30 days, and then you can prolong it, but the specification doesn't say anything about that. So, since my HTML is messed up, I'll try to do the rest of my talk through this document. Actually, I'll set my notes. Oh yeah, that's the interesting part here is that the judge's name appears on the warrant, and then there's the certificate. I hope this is redundant and that actually the judge's name is in the certificate as well, because otherwise how is it protected by a digital signature at all? There's this thing I heard rumored a few weeks ago that at HAL there's this thing called a blank warrant. Apparently some police officer here have blank warrants, and apparently they can sign it, and then they issue it immediately. I have no clue how this is handled in the XML spec.
Excuse me, is there a namespace?
There is an example.
There's no reference in there, this XML.
The XML is the only example we have. There's no DTD, there's nothing official. We have the example to go by. So whatever namespace is used, you've just seen it. Okay, the handover interface 1, which we were talking about, which sets the warrant, which is the XML code, will be shipped, as far as we know now, on CD, which provides another interesting point. If it's a CD, we're going to get a read-only media. So how are we going to do this key exchange? So apparently we have to do that beforehand, and so we have the keys so we can type this in. Oh yeah, some detail. The target key, if you use RC4, then we just dump 40 bits. But I guess by now we should all be using Rindal anyway, which is allowed as well. Okay, handover interface 2, I covered that a little bit. Let's go to 3, and there's an overview picture which I'll just launch. Okay, there we go. This is the basic setup of the system. You've got the ISP on the left, you've got the government on the right, and the evils in the middle. S1 are the tapping boxes that are actually doing the tapping. They can have multiple boxes per ISP or per location, depending on your physical structure. You won't be able to backbone. And of course there are problems that if you have a large pulp and there are 2 users and you wish to snip the traffic there, then you will never get it to your backbone. So you can have multiple boxes, and not everything is even solved yet. If 2 users end up in the same modem pool, in the same physical device, how are you going to tap this? It will never get on your network. The government just says, well, you need to tap it, it's your problem. The S2 box is the central collector of the ISP. It basically collects all the information from the sniffing units and then securely transports it over the insecure internet to our government somewhere in Amsterdam on the Amsterdam Internet Exchange. So, the government receives it actually the government receives it on T1. And T1 is a machine that's specified in your warrant and can be anywhere in the world. Actually, I hope it's somewhere in the world where we don't know, so that any target cannot do a denial of service on that, so that it's really unknown where it is. You can imagine that if this machine would be located at the ITO, which is the government branch of the IT department that does all the secure things. These are the people who have the Amsterdam Internet Exchange big pipe where all the tapping data is apparently coming in. This is another problem the government has. They have a big pipe to receive tapping information. You're not going to hide them from us. There are too many network people around here who can figure out where big pipes end. So I'm hoping actually that T1 is somewhere out in the world. We don't know where. We just send it to it securely. And then since no one knows until the warrant is there where it is, then T1 can safely transport all the way up to T2, who will be the other end of the big pipe here in Amsterdam.
How big is the pipe?
It's on the Amsterdam Internet Exchange, so that's either 100 megabit, I think. You can just get a Ethernet port here. Maybe you can get something bigger these days. Is there an Amsterdam Internet Exchange person here? Well, at least 100 megabit. That's what I got from the connection at least. We also know, from this connection, we also know the MAC address, the internal MAC address, loopback, IP numbers. We know where this connection is, it's just that we missed the port. As you can see, we took a picture of it. Actually, I took a picture of it, and I don't have access to Amsterdam Internet Exchange. So it's very secure. Okay, so S1 and S2, which are the boxes of the provider, should be invisible. So if they're sniffing, then ideally you would have to come to the descent wire on the sniffing interface. Unfortunately, hubs and switches will then no longer recognize it, so you have to do other things. You could do things like do an outgoing filter on your own MAC address. I'm not sure if that's acceptable to the government, but I think it's a good solution. I know Linux supports it, and I'm sure BSD does as well. Okay, S1 and S2 may be on one single machine, so it's nice for the government to reduce the cost because we're all paying for it ourselves. If it's not, then you should have a secure connection. S1 must use NTP, which is interesting because S1 should be hidden. So, okay, well, we compromise. We say that S2 may provide the NTP server. I talked briefly to Ian Goldberg, and he said that this wasn't a very secure setup. So apparently you can mess around with timestamps. I don't think it will buy you anything if they're doing it properly, because the data is still coming in like sequential. So there might be some packets that are back and forwards, but I'm sure we can figure it out, because the encryption also numbers all packets. So I don't think that's too much of an issue. You can mess a little bit. Okay, I talked about T1. I hope it's really hidden and that it's really random and that I don't know it beforehand. You can imagine what if an ISP wouldn't want to tap or would like to tell its users when they're being tapped. They could just publish a list of filters and then put the ITO in the filter. Then if they need to tap, they need to unfilter ITO and need to remove it, and then everyone else, oh, there's a tap going on. It's illegal to show that there's a tap going on, but if you filter them, you can't give them information anyway. So you can maneuver yourself into a tricky situation where you have to give the information. So I wouldn't recommend trying this. There can be multiple T1s on the other end. So again, this one, there can be multiple T2s, so this one can send it to other machines. Okay, then we go to the encryption part. Okay, so the most important encryption is, the most important link is S2T1. That's the one that goes over the internet. That's the one you want to monitor close. That's the one people want to see. That should be really secure. So we're using IPsec or SSL. I think most of us went for SSL because of the IPsec interoperability problems. So I guess SSL is better. I'm not sure. I haven't had any experience with interoperability problems there. But since the government all wants us to use open standards and open implementations, I'm sure they're using OpenSSL. Is Spine using OpenSSL? Or IPsec? Okay. There's lots of secrecy going on about these things there, unfortunately. Okay, S1 needs to do the encryption. Some providers ask, like, is it possible for us to let S2 do the encryption and S1 just be the sniffer? Of course, they don't want to do that because then the connection S1, S2 has to be really secure. So S1 is doing the encryption, and every 5 minutes or 64 packets, they will send out a hash as well. I'm still not entirely sure why the government wants the hash there. Because either you trust your crypto tunnel or you don't trust it. This, since S1 numbers the packets as well, you could see when the packet is gone. There doesn't seem to be a real reason for it, or at least I haven't understood it correctly. And then T1 has to check these hashes, and it will check and see if all the packets arrived. Which I think if you're running SSL tunnel or iptrafic tunnel, you're pretty sure they arrived. And then T1 sends the plain text to T2. And there are a few weird things. You need to tear the tunnel down as soon as possible. So if there's a problem, so if go back here, so if S2 cannot receive any information from S1 anymore, it should tear the tunnel down between S2 and T1. And same on the other end. If T1 cannot reach T2, it should tear down the tunnel between T1 and S1. And also if the user stops, the tunnel should be immediately closed. There should be no delay. However, you're allowed to use pseudo packets, so that traffic analysis becomes more difficult. So how do I send pseudo packets when I have to close links immediately? We're still susceptible to the traffic analysis problem. Okay, well, these look probably very horrible now without any layout. These are some of the C structures. If anyone's interested in links, I will give it to them. They're all...
And that's the standards that you have to have certain uptime or quality of service, or can you implement with Windows, for example, and then
the uptime, as the government specified, is their machines will always be up. No. You have to be always up. However, if for some reason you're down, you're not allowed to buffer any packets, you have to dump them. You're not allowed to store any data of the user. And you have to fix the problem and you have to notify them immediately.
what about buffering? Be a problem.
The only buffering I think that sort of allows someone in the operating system with a TCP stack. You're not allowed to add your own layer of buffering. They don't want user data that's intercepted to be at the ISP. They would rather have it that it's gone than that's at the ISP.
It could be a great problem. Because, as you mentioned, the buffer in S1, you are secret. You want to send the information to S2,
There's another reason they don't want you to buffer. If you buffer, that means that they get the information later. They want the information real time.
Okay. Is what we were talking about buffering memory?
And you can also buffering the connection if the connection is down. So if the connection is down for 5 minutes because half of Amsterdam is without power and the Amsterdam Internet Exchange is down, like what happened last month, then you're not allowed to buffer. So so the government is never down, except when Amsterdam is down as well, like it happened last month for about 5 or 6 hours. Everything on the Amsterdam Internet Exchange was down. So ITO was down, so presumably their interception unit was completely down.
Doesn't the scheme open the justice point up for the now certain text? I mean, if I were to know that I was being tracked, nothing would stop me from doing random packets to the internet, which they have to receive and forward to their own machine as well.
Yes, of course that's possible. That's why these documents were, well, you can't make it secret because it's a law, but they tried to make it as secret as possible. Yeah, sure, one of the reasons is the unilateral service attacks, which you can do a lot more than that. Imagine you set your NTU to like 10. Remember, every packet that's sent needs to be encrypted. So your snippets will not be able to encrypt it, and they will not be able to decrypt it in time. Yeah, you can copy ISO images of Red Hat back and forth until this one goes down. So of course, it's fairly easy to give them a lot of work, but that requires that either you know that you're trapped or, well, you're not using your connection for any real thing.
Well, what you can do is, when you're not using it for a real thing, like this, they simply try to do some random traffic into the unknown. They then have to do it.
Well,
Everybody has online, either by cable or anything.
But that's why we have these many police officers trying to search for your data.
Is there any specification on the bands that you have to have available for that? I mean,
Yeah, that's indirectly defined by the fact that you are not allowed to make it visible to the user that he's being tapped. So if you have a customer that has a 1 megabit connection and that needs to be tapped, then you better have 2 megabit. Actually, a little bit more because you're encrypting as well. So you still need to give the user 1 megabit because he's not allowed to hear, and he's not allowed to notice a decrease in performance because that might lead to him realizing he's being tapped.
It means that I have to double all my uplink connections.
Yeah, no, but you're not allowed to double because he might realize that because you're doubling, you're tapping. Officially, any layer of encryption that the providers give to the user, they need to remove. I think I heard that access for all. You're not allowed to engage in any new activity to this user. So you're not allowed to change your service. So if you're just a provider relaying SSH packets, you're not allowed to change that and accept them or do man-in-the-middle tags. But well, if the government wants to do it, the government needs to do it. Yeah. The provider is not allowed to change their service to the user. But the interesting thing is that it's mandatory to remove any layer of encryption that you as a provider have. So if you're using secure webmail, forget it. That in theory the user has to, the provider has to remove that encryption layer and send the plain text. With mail it's easy because they already have the plain text in the mailbox. With SSH it's more difficult, and I heard that there was a lottery of access for all to send an SSH patch to OpenSSH so that they could save the keys to their network stored on disk. Because SSH is basically illegal now in current implementation because it's not possible to get all the keys. Sorry? Okay, I will need about 4 hours to give you the full answer to this, and it's a huge politic thing. So I'll give you the short answer. If you get a tapping request, you're obliged to comply with this system. But I don't think it's online yet. But actually, a week ago there was a notice that the first email tap had been done, but I'm not sure if they used it. I don't think they used it. That's another interesting question. It's another political question. It has been asked of the government, is there any certification process available and what happens if someone wants to make an open source implementation? I don't know the answer. I don't know if they've answered. I don't think there was a reasonable answer, or I don't know it. Mind you, I am a very small provider. I'm not an access provider. I'm just a web hoster. So the status of my company is very strange. So if I follow the letter of the law, I need to be tappable, so I should know all these rules. However, they make an extreme thing where I have to be a member of the telco organization, which requires me to pay lots of money, and there's no single web hoster in the Netherlands who is a member of this telco organization because it's not meant for web hosters. So I cannot get the specs, I cannot comply, but I need to comply according to the telecommunications law. It's a very dubious stage where I'm currently in. Well, since I've sort of told what I wanted to say, let's just go continue with the questions, if there are any more. Okay. Why do you people keep asking political questions? Okay. It was guaranteed that it would. The question was, can you estimate what the price would be for a large ISP to implement this? Because they have to pay for it themselves. The government guaranteed at some point that it would not exceed more than 5% of your turnover.
What's the guarantee? How do they back the
No,
guarantee?
no, they used to guarantee this. Yes. If you just run a sniffer and you make sure that you only have like link layer connection to your switch or hub or to and then make sure that you filter on your outgoing, your own MAC address and outgoing, and you should really never be able to do anything, not even answer ARP. Because if you filter on IP, you will still send ARP replies.
Do you see the sort of thing being implemented not only in ISPs, but say large organisations like universities and stuff, which have a large user base with connectivity?
I'm asking political questions. Okay, officially, the telecommunications law states that. Oh, sorry, I'll repeat the question. Who needs to be tappable is basically the question. Large organizations like universities as well as ISPs or not? Okay. Again, the telecommunications law states that everyone offering a public telecommunications service needs to be tappable. Public has a legal meaning here. Public means like you don't discriminate at the people you serve. So any ISP that takes on anyone who pays is considered public. Universities are not considered public. Large organizations like in the Netherlands there's a large organization called HSCnet, which is huge, which could be considered a provider, except that you need to be a member. It's dubious whether or not they should, whether they need to be tappable or not. SurfNet, all the universities, in theory, if you follow the letter of law, they shouldn't be tappable. I'm sure they're having major fights right now behind the screens. Any more questions? Yes. From a lead, okay, well, the question was, are T1 and T2 in the Netherlands or can they be elsewhere? Or if they have the same location. They don't need to be in the same location because the T1 and T2, S1 and S2 and T1 and T2 are defined as, if they go over untrusted network, then they should be secured through the similar IPsec or SSL connections. So this becomes a legal matter more. Can the Dutch government put T1 in Belgium? You're getting into a legal fight where you don't know who owns the traffic where it's going. So my guess is, okay, if I was the Dutch government, I would put T1, I would vary T1 a lot and put it at different places with high bandwidth. And I try to hide T2 in my own location. And I know it's going to be, people sort of know where it will be, but as long as I'm protected that only my T1s can talk for it, it should be reasonably okay. So I should try to get this out of, keep this out of all the public peering agreements, and do just private connections between T1 and T2. There was another question somewhere there.
I assume you are not allowed, as an ISP, the government sets you 3 black boxes.
No. What do you mean the government sends you? You need to have these boxes.
Yes, you need to have these boxes, but you are not allowed to disassemble or analyze these boxes.
Oh, no, okay. The people who if you're getting a tapping order, then I assume that the government agrees that you should know the specification, so that you can actually have these boxes. There is talks about an intermediate organization who will lease out these boxes, but that's one political fight as well right now. But basically, if you receive an order, you should be able to comply.
You can specify who owns which boxes.
Okay, sorry. S1 and S2 is owned by whoever needs to be tappable. So that's the providers and web hosters and universities. T1s, and T1 and T2 are the global interception units. So that's the police. Up there?
But S2 is controlled by the provider, so how can you guarantee the anonymity of T1? Because the provider can still use your
Because the security officer at the provider is the only one who should know about S1 and S2, and if he leaks out that information, he's breaking the law.
Yeah, okay, but even small organizations need to have S2 placed. So, and if only one knows the location of T1 and spreads the word, it's
T1 can be changed all the time because it's only valid for it's specified for warrant.
so how are you going to let S2 in all organizations know where T1 is through letters or mailing or something? Or
There can be multiple T1s and multiple S2s. So if provider A has an S2 box, he can talk to another T1 than provider B. No one says that the Dutch government has only one T1. They could, but I don't know. They're probably on non-disclosure as well.
Looking at it in a sort of like more multiple states relating, so you could have a situation where there's multiple T2s and multiple T1s. It could get awfully messy for the people who are having to feed up the streams if they're having to trace people across different country borders and stuff. Yeah?
Yes, I don't think, if you got multiple T1s and T2s, I don't think you want that on cross-country. Unless you have really good European negotiations. Like, I don't know how far cybercrime treaty goes to, because governments need to cooperate with each other. So you could say like, well, I'm putting this box at the links in London because that's better for me in this case, because we suspect more traffic is there, and that maybe the UK has to cooperate. Depends on how you interpret the cybercrime treaty. I'm not an expert at that. You might not ask what is Western. You first, then you.
Have they done any threat assessment on maybe uncooperative paranoid or ISPs, so they want to comply, but do it by the letter of the law?
If there's a disagreement, the user answer from the government is this will be fixed in bilateral negotiations. Everything that's unclear is like administrative issue agreed upon later. Basically, they tell you what to do. There one? Yes?
Yeah. Do you think there's a market for these sort of tapping boxes among...
About half a year ago, there was a Vendor Day in the Netherlands, organized by the Dutch NLIP Association. All the boxes there were vaporware, as far as I could see. They were not done because the government was way too late with all the specifications. There's definitely a market for it. You can see all the French companies were there, a bunch of Americans were there. That guy was there, he was, I think, the only Dutch party. Can you say that, or is that anyway as well?
I think there were other Dutch people there, but they were part of other international...
Yeah, there was one organization I talked to that refused to send me any information on their machine when they realized, or actually when I told them, like, listen, I'm not a potential client, I'm putting this out in the open, I want to talk to people about it. I got an anonymous email with the brochure that all the people got, and it was basically carnivore type system with a one-liner on top of it saying, there's a Dutch version. Well, the carnivore is totally different. So how these American companies are doing is that they're racing. I think mostly the European companies are racing to get this done because whoever sells the first few machines in the Netherlands has a very good chance to sell all the machines in Europe. There are two open source initiatives that want to make these boxes in open source for free and open so that everyone can see that they're a minimalistic approach and not a feature-rich buy me box. Because that's of course the danger you have when you buy black boxes. Both open source projects, as far as I know, have no single line of code yet. One appears to be rather dead, and the other is waiting for funding. Yes, no?
So if I ran one of the T1, T2 operations off of my net back in the United States, say, and some...
Are you a government?
No, but so what? It's just a protocol.
Oh, okay.
Yeah.
Okay, go ahead.
And then suppose some unrelated party, sent a letter to an ISP saying,
well, we have
you're
digital.
required to tap this person and send it to that IP
Well,
address.
we have digital warrants to prevent that. So we've got a signature, a digital signature from the judge, so they will see that, hey, this judge is John Gilmore. I don't know this judge. Let's look at the PPI in the Netherlands and let's see if it's signed by DigiNotar.
You mean the PKI that you don't know?
Yes.
The NBA PKI.
I don't think in general government employees are better paid than ISP people. There were more hands. Yes, you.
Can you actually imagine the government funding an open source implementation of these laws?
But if Mr. Goldman is here, maybe he can answer that question. No, Mr. Goldman? Or at least anonymous. I would love to have funding. I'm one of the open source projects with 0 lines of code. I would love funding. I would start tomorrow if you give me funding. In the end, it would be a more fair solution and probably cheaper for everyone involved, because now there's this tricky problem with cost, because the Dutch government is paying for the variable cost. So if you need to send an operator into your co-location to enable the tap, and he costs $250 an hour, you get that reimbursed. You don't get the machine reimbursed, but you get the personnel cost reimbursed. So now there are tricky political games where they try to move all the costs into variable costs. So yes, so if the government is listening, I think it's really cheaper if you just make sure there's an open source implementation. Next one.
What can I do to something provider people not comply or
I guess you would get his Delta license revoked.
And wouldn't that make it public that they were trying to do tap sweeping?
Yeah. But I don't think there are many companies that will be willing to do that.
I'm sure there's a lot of mistakes that can happen between S1 and S2.
You're not allowed to make mistakes. You should buy either a good functional certified product or have a really good open source implementation that we can all debug. Thank you.
Do you have enough data, public data in the public sphere for this country, such that you'll be able to tell if there's a massive rise after the system is implemented in what the government's looking for? Presumably they've been doing some amount of tapping all along.
Yeah, yes.
And the question is, once they force you to implement their toys, will they use them a lot more?
When the system will replace all the unique agreements between all the different parties involved, it should become easier for the government to do more tapping, because it's more automated than the current system where they go to a provider and say, we need a tap.
Do you have a way to monitor this? To tell, in 2 years you can be able to say, with this system in place, tapping went up 3,000%.
I think there are about 150 people who have access to the MRTG statistics on the Amsterdam Internet Exchange for ITO.
I don't know if that answers my question.
That's the connection of the government.
Okay, so
That's
there is no legal FOIA in place for total volume of tapping reports per year.
Talk to Maurice Wessing about that. They're very reluctant in releasing figures already. We got tapping figures from a few years old. The only thing we know is that in absolute numbers, we're tapping more than the US. Yes, digitally.
Are you certain?
No, I'm not certain about that, because there are blind warrants here at HAL, I heard. And I don't think there's a judge walking here. Yes, you?
does the new open
I think no, T1 opens the connection to T2 and keeps it, and as soon as it realizes it needs the connection, and will terminate it as soon as it sees a problem or it doesn't need the connection anymore. Yes?
So, what prevents this system from being used for being abused politically, say by wiretapping the opposition to the government?
Sorry, abuse how?
Well, once the system is in place, then anybody who can issue these digitally signed warrants can basically tap anybody at any time. What prevents it from being abused politically to suppress dissent or to oppose the government rather than against real criminals?
Well, can you answer that? I can.
So, are there any checks and balances in the system?
Yeah.
Okay. Assuming that if you're a provider, I would assume that for now you will not trust the XML, and you will call up the police and ask, listen, is this okay? Probably, since you're going to get a CD anyway, someone has to physically give you the CD, so maybe you can do it through your phone calls then.
Before or after you start.
Highly unsecure.
Sorry?
Phone calls are highly unsecure. I mean, so it could very easily be corrupted by their own.
Use a digital signature.
No, I mean, because you have the same telephone number with the police because you live in the spot next door. So I dial one wrong number and say, is there a warrant issued against Mr. Storman? Blah, blah, blah. And they said, oh, sorry, it's not the wrong number.
You have a contact call with the villain.
Yeah. Any more questions? Yes. Yes, the internet provider gets a. But anyone receiving the traffic warrant will receive a CD. Well, the internet provider should put the CD into S2, and S2 should then instruct the S1 boxes what they need to tap. No, it's digitally signed. You can't change the warrant.
Besides, you might try to encrypt the CD. So you...
No. The CD contains plain XML. Of course, the next step is to not do this with a CD, but do it through the internet. And then, of course, the next step is that the provider doesn't need to check anymore because the certificate is valid, right? So the next step is that the provider doesn't need to supply his own blocks, but the government will do it. And then no one knows what's going on.
That's possible. A lot of our speakers in the Netherlands will not do this.
No, all ISPs must do this.
I'm not talking about must do this, I'm talking about not checking.
A lot of the ISPs will check the reads before they give it out. You're saying a lot of the ISPs aren't doing this in the future. I don't think that goes to an ISP which is not checking anymore, and it's just maybe there's a let's say.
How would you?
I surely hope so, but if there's one ISP left in 10 years, then you don't have a choice anymore. Look at AOL. AOL is censoring and it's a commercial success.
But you're talking about the Netherlands here, and at the moment there are a lot of ISPs.
Yes, okay. Let me get back to this. There are a lot of ISPs. Can we have some lights? Or?
It's sorry, we have to wrap up for the next session very soon.
Okay, so give me 1 minute and I'll wrap it up.
You're a little over time.
There are a lot of ISPs, and a lot of these ISPs cannot afford the system. So either these ISPs will die, or they can only survive until the first step will arrive. That's not a problem. So the current law says that you must be ready. You don't have to have this infrastructure in place. You just have to guarantee that if the attack comes, you're ready to handle it. You will see that ISPs, especially the smaller ones, will kick away users who might risk them getting attacked because otherwise they will go broke. So this directly influences freedom of speech. Okay, if anyone has any more questions, I suggest that you hunt me down somewhere.
Yeah.